Comparing 2p. Which of two popular drugs lower blood pressure more? Who studies more in college, men or women? Who uses social networking sites more, teens or adults? These are all viable questions in the real world that could prompt studies. The difference between these questions and the ones we have worked with thus far is that we are comparing two proportions or means. Up until now, we have only worked with one sample intervals and tests. The next two topics, meaning this one and the next one, will cover how to handle two sample confidence intervals and significance tests for proportions and means. Don't confuse this concept with paired data. Paired data consists of pairs of observations that are matched in some way, such as by time, by individual, or by location. The goal of analyzing paired data is often to compare the two sets of observations and determine whether there is a significant difference between them. Most importantly, with paired data, the subtraction occurs at the beginning, and its results become the data used to find the confidence intervals or conduct significance tests. We will see in this topic how, when finding confidence intervals and significance tests of two proportions, the formulas themselves, while similar, will be different. Take the first question from the first slide in this topic into consideration. What if we want to test the effectiveness of two different types of medications for blood pressure? Let's start with what our shape, center, and spread would be when working with two proportions. Given an SRS, or a simple random sample of size N1 for population 1, with a proportion of successes having a value of P1, and a separate independent simple random sample, or SRS, of size N2 for population 2 with a proportion of successes P2. For the shape, if all of the following are true, N1 times P1 is greater than or equal to 10, N1 times 1 minus P1 is greater than or equal to 10, N2 times P2 is greater than or equal to 10, and N2 times 1 minus P2 is greater than or equal to 10, then the sampling distribution will be about normal. Regarding the center, the mean of our first sample proportion minus our second sample proportion is equivalent to P1 minus P2. Regarding the spread, if the sample mean is less than the sample population, the standard deviation of sample proportion 1 minus sample proportion 2 is given by the formula, which is the square root of P1 times the quantity 1 minus P1 all divided by N sub 1 plus P2 times the quantity 1 minus P2 all divided by N2. The conditions for a confidence interval of our sample proportion 1 minus our sample proportion 2 are as follows. First, it has to be random. The data has to come from a well-designed simple random sample. Condition number 2 is 10%. When sampling without replacement, the population needs to be at least 10 times the size of the sample. In other words, our sample size must be less than or equal to 1/10 times the total population. It also has to follow large counts. The successes and failures in each sample, which are N1 times P1, or N1 times 1 minus P1, N2 times P2, and N2 times 1 minus P2 all have to be greater than or equal to 10. The standard error or estimate standard deviation formula does change when you have two proportions. The standard error becomes the square root of P1 times the quantity 1 minus P1 all divided by N1 plus P2 times 1 minus P2 all divided by N sub 2, while the formula for a two-sample Z interval for two proportions is our sample proportion 1 minus our sample proportion 2 plus or minus Z star times the square root of P1 times 1 minus P1 all divided by N1 plus P2 times the quantity 1 minus P2 all divided by N2, where Z star is the critical value for the given confidence interval percentage. Here's an example on how to create or find the confidence interval with two proportions. Suppose we want to compare the proportion of male and female students who own a car at a certain university. We randomly sample 100 male students and 100 female students from the university and find that 70 of the male students and 60 of the female students own a car. Construct a 95% confidence interval for the difference in proportions of car ownership between male and female students. The first thing that we need to check is that all of the conditions are met, which they are. And we can prove this because we have a sample of 100 male and female students from the university. Those are good quality, simple random samples that are created. And then for the 10%, the population needs to be at least 10 times the size of the sample. So there's definitely more than 1,000 male students within that university, and there's also more than 1,000 female students at the university. And now let's look at the large counts. So our N1 for the male students is 100, and the P1 value is 70 out of 100, or 7/10. And if we were to multiply N1 times P1, we would get 70, which is greater than 10. So that one works. The same with N1 times 1 minus P1, because 1 minus P1 will be 3/10. Multiply that by 100 and you'll get 30. That's also greater than 10. For N2, we also have 100 students, 100 female students, and P2, they tell us it's 60 own a car out of the 100 that we surveyed, and that's equal to 6/10. And if we were to multiply N2 times P2, we would get 60, that's greater than 10. And if we did N2 times 1 minus P2, it would be 100 times 4/10, which would then equal 40, and that's also greater than or equal to 10. So yes, definitely all of the conditions are being met. So at a 95% confidence interval, our Z statistic is 1 in 96/100. The next step that we have to do is to identify the necessary values to use within our confidence interval formula. And remember that confidence interval formula is the sample proportion for the first one minus the sample proportion of our second set of data plus or minus the Z star value times the square root of P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 all over N2. Well, we again already figured out what P1 and P2 are, and they are also equivalent to our sample proportion for each sample that we have. So P hat 1 is equal to P1, which is equal to 70 over 100, which is 7/10. And P hat 2 is equal to P sub 2, which is equal to 60 over 100, which is equal to 6/10. And we know our N values for both samples is 100. If we substitute these values into our formula, we will end up getting 7/10 minus 6/10 plus or minus 1 in 96/100 times the square root of 7/10 times 1 minus 7/10, all divided by 100, plus 6/10 times 1 minus 6/10, all divided by 100. And then if we substitute those into a calculator, we get about 67 thousandths, the square root, and then when we multiply that by 1 in 96/100, we end up getting about 131 thousandths. And then if we add 1/10 to that, we get 231 thousandths, and if we subtract a tenth from it, or if we subtract 131 thousandths from 1/10, we end up getting negative 31 thousandths. And now we can interpret our results. We are 95% confident that the true difference in proportions of car ownership between male and female students is between negative 31 thousandths and 231 thousandths.